Welcome to the Water Resources Database Management System webinar series. This webinar is produced by the Water Protection Division, TMDL Development Section, EPA Region 4. Today's webinar will show how you can use the Water Resources Database to process output from watershed models. What's going to be covered in this webinar is we're going to give an overview on how to download WRDB. We're going to review watershed model concepts, the idea of what goes into a watershed model, what comes out of a watershed model. We'll take you through the process of taking watershed output and bring it into WRDB, and then ultimately take you through the steps where you can export the watershed results to other models. To download WRDB, you need to go to www.wrdb.com. Click on the download link on the left-hand side, and that'll take you to where to download. Also on the WRDB website is a link to the introduction to WRDB webinar. We assume that you have seen this webinar or have good knowledge of WRDB before continuing on with this one. A little bit about the watershed model concept. Most watershed models break the watershed up into subbasins. These subbasins represent individual drainage areas or catchments. Within each subbasin, there are several things that are characterized in the watershed model. One is land use types, urban areas, agricultural areas. These are typically used for determining pollutant contribution as well as runoff as a function of impervious area. Soil types, which are used to calculate infiltration into the groundwater. Slopes and stream reaches for routing the water off the watershed or subbasin. Watershed models are typically forced by meteorological conditions, things like wind speed, solar radiation, dew point, air temperature, and the big driver of all is rainfall or precipitation data. These models can handle precipitation data typically from hourly to daily rainfall to predict contributions from the landscape. Each subbasin has a pour point or an area where all of the model calculations are represented. In this case here where the arrow is, that's a pour point for our subbasin, and it's at this pour point that the watershed models can provide time series data for runoff, pollutant loading such as BOD, total nitrogen, and total phosphorus. So it's from each one of these pour points from the subbasins of the data that we would process with WRDB. So that gives us a brief overview of the watershed model concept. So what we're going to do next is we're actually going to demonstrate how WRDB can import watershed model results, the output files or result files from LSPC and HSPF. We're also going to look at how to make calculations, graph the time series results, and then ultimately process the data for other models. Okay. We're going to import some data into WRDB. We assume that you've already created a project. In the case here, mine is called Watershed Example. I have to create a working table for the watershed model results to be stored in. You would create a working table for each specific model output run that you would want to process. So I'm going to click on Work, Create New. I'm going to call this existing condition. So this is my current calibration run. So this creates an empty table. Now, there are several ways to get this data into WRDB. If you click on Edit, Import, and Import Data, you will see that WRDB supports many different types. We can import LSPC output files, watershed data management files, WDM files, which are a result of running HSPF. For our examples today, we're going to work on LSPC output files. Now, WRDB has a direct function for doing that. So I'm going to hit Cancel on this and go to Edit, Import LSPC files. Now, LSPC stores the results from each one of the individual subbasins in its own OUT file. So in my run here, I have 6 subbasins, so I have 6 files, 1 through 6. The file name, the 1, 2, 3, 4, 5, and 6, represents the subbasin ID that was described to LSPC. So to process all of these, all I have to do is click on one of them and say Open. WRDB opens up this import dialog box, which allows you to pick which subbasins you would like to pull into the working table. In this case, I'm going to say all of them. Now, the subbasin IDs in the LSPC run will ultimately become station IDs in WRDB, so that you know where they are in space. The next thing we need to do is pick the parameters that we'd like to import. Now, LSPC has a whole host of outputs in its out file that you may or may not need to import. The major ones that I'm going to be going for here is RO, which is actually the runoff rate or the outflow rate from the stream network, and it has units of flow cubic feet per second. The next thing I have to do is go find the concentrations of the constituents that I want to use or pull back into WRDB. So in that case here we have cons 1, 2, 3, and 4. What WRDB does is it actually uses the metadata of the LSPC out file to give you a description of what cons 1 is, and in this case here it's BOD 5, cons 2 is total nitrogen, cons 3 is total phosphorus, DOX is dissolved oxygen concentration, and the last one we're going to bring in is water temperature. So we selected which subbasins we want, and then we've mapped the constituents from the LSPC output file into our WRDB structure. I click OK. What WRDB is doing right now is it's processing each file one at a time, and you can see the updates of where they are right down at the bottom left-hand corner. And this is going to take a moment, but what it's doing is it's extracting out of those OUT files and you're putting it into a format that can be readily used by WRDB. So it's sort of a two-step process. It's the data is exported into a temporary file, and now it's saying, let's go ahead, do you want to import it? Now, my LSPC stations don't exist in the stations table, so it's asking me, hey, is it okay if I add these? I'm going to say okay. So it will push those into the stations table, and then it'll read all of the data into the working table. So in a second, we'll have the LSPC output results. So here's our table with the results pulled in. Okay, once we have the LSPC model results pulled into a working table, we can use many of the features that are built into WRDB to look at the predictions from the watershed model. One of the first ones I'm going to do is I'm just going to run a simple report that's going to show us the contents of this working table. I'm going to click on Output Reports Summarized by Station and Parameter. And in our case here, station is actually equivalent to the LSP subbasin. And if we look over here on the first column, we can see that we have all 6 of our subbasins, each one of the constituents that were simulated in LSPC. We have the number of observations, the mean, the min, the max, the first date, last date. So basically, we have daily output for each one of our subbasins from January 1st, 1996 to December 31st, 2009. So quickly we can see that we've imported quite a bit of information. The other thing we can do is we can actually look at it in time series mode, where we can actually plot it. So we're going to use the plotting routine, output, graphs, time series, and we're going to use a tool that was described quite extensively in the intro, but I'm going to plot all of the constituents for subbasin 1. I'm going to use a build function where I'm going to say build multiple tabs by station and P code, and I'm going to select just subbasin 1, all of the parameters. I'm going to put a title on there called LSPC subbasin 1. I'm going to say OK. And I'm going to add these 6 tabs or 6 graphs to the graphing utility. So here is the total phosphorus for our simulation period, total nitrogen, water temperature, the flow, and we can see that we've had large periods of time where we had large rainfall, dissolved oxygen, and BOD. So we can see real quickly in a time series graph what our model results look like. So The Water Resources Database is an excellent tool for processing these large amounts of time series data and summarizing them. You can use the graphics utility to do publication quality graphs. You can use the reports to give summaries of what was predicted by the Watershed model. Okay, we are now going to process the LSPC Watershed time series results and pass them on to a water quality model. In this case here, we're going to use the example of using WASP, but there are many, many different ways to do that. As shown in the PowerPoint previous to this, we're only interested in sending one of the subbasins to the water quality model, and that's subbasin 1. So what we're going to do is we're going to execute a query to separate out just subbasin 1, and we are going to pass to WASP the flow, the BOD, the total nitrogen and total phosphorus, and the DO. And then we can actually pull the water temperature data in as a time function. So what we're going to do is we're going to hit Advanced Query, the binoculars, and you're going to get a form that looks like this. We're going to send all of the P codes or the parameters over. So, but we really only need to send one station, and that is station or subbasin 1. So what this query basically says is I want you to select from this working table everything that is in station 1. So if I hit execute, the data is subsetted into a working view. So now if I actually use the output report summarized by station and parameter, we'll see that we only have one station and all of the parameters. Okay, so now we have options. We can export this data using the output export function. And if you go to data file, you have the option to sending this information to tab separated text file, spreadsheet files, a paradox file, a DBase file, even a WDM file. What we're going to use for WASP is, because the current version of WASP supports paradox tables, we are just going to send it to a paradox file, and I'm going to just put it over in the same directory where my my WASP input file is at, which is over here in WASP. And I'm just going to call this actually LSPC, and it's going to have the extension DB, and I'm going to hit save. And what WRDB is doing now is just writing this external file called lspc.db. And what we're going to do is we're going to actually link WASP up to this external file. Okay, what we're going to do now is we're going to look at the process of importing the LSPC watershed results that were brought into WRDB and bringing them into a water quality model. We're going to be linking the LSPC model with WASP, and we're going to be using an option in WASP that has an external data linkage, which allows you to point the time series input of WASP to external files. Currently, the version of WASP supports paradox files, Excel files, tab delimited text files. We're going to be using the paradox file format because it's just a little bit easier to use and it can handle large sets of data. Now, no matter what kind of file format you're using, there's required fields that have to be in these external files that have to be linked up to WASP. There has to be a station or a location, in our case a subbasin ID, that's going to be represented and linked to a specific WASP segment. There has to be a date time field so that WASP knows where and when to apply it in the model. A parameter code so that we can actually subset the data going into WASP so that we know that nitrogen's going into one of the nitrogen groups. And then finally, a result value. In other words, what was the model prediction to the actual number. So you need at least those four fields for this to work, whether you're using WRDB or any other program. You can have external linkages to these files for any of the time variable functions in WASP, such as flows, boundaries, loads, and time functions. So let's just look real quickly at what we're going to be doing. I have a simple 9-segment system. We're actually going to use the water temperature that was predicted by LSPC coming off the land surfaces to drive the water temperature in this segment. And of course there's other ways to do temperatures in WASP. We're going to use the time series of runoff flows at the top of our basin to come into segment 1, as well as total phosphorus, total nitrogen. And then once we get these linked up, we'll make a simple run. Okay, now we're going to just give an overview of how to bring in these external files to WASP. Let me just take you through quickly our simple setup we have here. We're going to be running the WASP model from 1997 through 2009. If you recall, the LSPC model actually started in 1996, and that's fine, but we're going to start in 1997. So when WASP goes to get the data from these external files, it will only pull the data started in 1997. We're using the simple eutrophication model. We have 9 total segments here. We're going to be bringing the results from LSPC Basin 1 into segment 1. On the flow screen, I already have the routing through the systems. It's just a simple straight shot river. So what we're going to do is we're going to actually link in this data. So that from the time pair functions of any of the screens, you're going to use this import function. You're going to go browse and find the DB file that we just created, and here's mine. Now, this DB file can contain it could contain hundreds of subbasins. In our case, it only contains one because we queried it out, but if it contained more than one subbasin, we would have to do a query on station, go find the station that we want. And then we also have to do the same thing for the parameter code because we have more than one parameter in here. Because recall we have BOD, DO, flow, temperature, TN, and TP. So we're going to want to have the flow in here. So now we're basically, WASP is saying, okay, from this file, I want all of the information for station ID equal to 1 and P code equal to flow. And it also says right here, restrict query date range to the model input, so it'll only get it from 1997 on. And if you wanted to test and make sure that this is hooked up correctly, if you hit this Run Query button, you'll see that the data will pop up right here, and you can even graph the data. Now, the last important thing is, and one of the big strengths of using this option is there's this option down here at the bottom where you can defer the input of the data until the model's run. Basically, that means that all of the data remains outside the WASP interface in these external files. So when you run the model, WASP actually starts to query the data out of these databases into the interface and then runs. The nice thing about that is if you're still developing your LSPC or you want to run different scenarios, all you have to do is replace this file and you would have updated all the time functions in WASP. You also have the option of saying, okay, let me just import everything into the interface. When you click this button, it'll query the data and put it into the actual WASP file and be saved. But we're going to use the defer option here. And I'm going to say okay. Now in the WASP interface, you will always be able to tell if a time series has been deferred because the grid will turn blue. So we've done the flows. Now we'll go on and do our boundaries. And I'm going to start up at ammonia, and this gets a little repetitive, but we have to get the TN data. So we'll highlight here, import, browse, go find the LSPC file, and we don't really need station because it was only one in here. So we'll go P code, total nitrogen, defer. We're done with that one. We do the same thing for nitrate, find the file, query out which P code you need, defer it. Do organic nitrogen, same thing, find the P code, query it out, defer it. Go to orthophosphate, get our file, query out the P code. In this case it's TP, defer. And then we would do organic phosphorus. Same thing. Then we would go on and do dissolved oxygen. So you can see this is a pretty redundant process, but once you do it once, it's done, and you can run as many scenarios as you want. The last one is I'm going to do BOD. So now we have linked up all of the boundary conditions. Just to show you that it can be used for the other functions, I'm going to go ahead and I'm going to bring in the water temperature. Same thing, browse to that file, insert, P code, temperature, and defer. So now we have the water temperature. And then lastly, I just need to come over here and turn water temperature on in WASP. Okay, with that, I'm going to hit save, and I'm going to hit run. Now, when WASP first starts to run, it queries all that data in, but then it takes off and runs. So we're looking at the time variable. Now, a couple things about linking LSPC to WASP. The first thing is, if we recall, the units are in cubic feet per second. So you could either make the conversion to cubic meters per second WRDB, or you could just put in the scale factor over here, which is the conversion of cubic feet per second to cubic meters per second. So we've done that. Now the other thing is, most of the times, because of there's not a lot of nutrient speciation data to calibrate the watershed model, we typically calibrate to nitrogen, total phosphorus. So the other thing you can do is, we did load total nitrogen into each one of these. We can actually use this scale factor, and based upon the ratios that we see in the data in the receiving water body, we can say, okay, well, 8% of it is nitrate, 32% of it is nitrate, and then the rest of it is organic. And then we can do the same thing with the total phosphorus. And basically what we've done is we have partitioned the nitrogen and the phosphorus into the different species. And now when you run the model, you would see that the numbers here are different based upon that speciation. Okay, just to finish up what we've done, we're going to go into the WASP post processor, and we're going to plot a couple of things just to see how and if the data was brought over. So I'm going to just plot for our segment 1 the advective flow. So this was the flow that came in from the LSPC time series, and you can see it started down at January 1st, 1997, and ran all the way through 2009. We can go ahead and also add total nitrogen. And this again should match what came in through LSPC. And we do the same thing for total phosphorus. So on. So you can see that we were able to bring in this time series data into WASP really easily for a very, very long period of time. So this is an excellent way to parameterize WASP when you're linking to watershed models, because after you calibrate WASP and LSPC to the current conditions, you can actually go in there and start to apply best management practices, do a TMDL. And all you would need to do with WASP is just overwrite or replace that LSPC.db file with the new sets of information. And you would have a new run without having to do anything else in the interface. That's it for this webinar. Look for more webinars in the future.